Hi, everyone. Welcome to our 7th lesson of the Python Bio VCN channel. And today we're going to be stepping into a slightly more advanced topic, which is actually used really heavily in bioinformatics, the Python Pandas library. And it's especially used under the hood a lot in Chime software, and it's extremely powerful for manipulating large and complex data sets. So let's now go to our website. So I'm going to start sharing my screen. So let's get started. So what is Python Pandas? This stands for the Python Data Analysis Library. Also, pandas are very cute, so I had to throw in an obligatory panda photo. So it's a Python library that's specifically developed for handling multi-dimensional data sets, which are stored as Python objects called dataframes. So this is a bit more, complicated and has more dimensions than, say, a list, right, which is a one-dimensional thing. And it has a lot of really, really useful built-in functions for sorting, filtering, and cleaning these large complex data sets. And these built-in functions can be a huge time saver. So I've sometimes been able to do in a couple of lines using pandas what it would typically take me, one or multiple loops of code to do in regular Python. And the great thing is that data frames are, in addition to being able to use the pandas functions, they're still compatible with normal built-in Python functions. And you can actually also use the data frame structure to further manipulate lists and libraries that have been sorted or manipulated in parallel somewhere in your workflow. So the basic data frame structure is really similar to what you might have seen in a graphic user interface spreadsheet program like Microsoft Excel or Apple Numbers. So there are rows and columns. And the great thing in Pandas is that you can actually refer to rows and columns by their zero-based Python indices, as we do with lists like 0, 1, 2, etc., by their position. But you can also refer to them by name. So let's see here. I'm going to launch the binder. Notebook is intended to go over the basic data frame structures and some of the more important filtering functions that are used in Pandas data frame analysis. So let's open here Python Lesson 7 notebook. And before I get started, I'm actually going to clear the output from when I last ran it. So I'm going to go to View, Edit, Clear Outputs. Okay, great. So there are multiple ways to declare and populate a Python Pandas data frame. And I wanted to go over these in detail because the formatting is actually very specific. And if you don't know how to do it properly, you will either get an error tossed at you, or as I've accidentally done before, you may overwrite a Pandas function and then have to uninstall and reinstall it. So there are 3 basic ways to do this. The first one I'm going to go over is declaring a data frame from a dictionary of lists. So we remember from our prior Python lessons that the dictionary is enclosed in curly brackets, and it's composed of key value pairs. So in this case, the keys are associated with a list of values. Here, I'm importing pandas, and then I'm having 3 lists of data set up for us to work with. So I have some OTU names, I have some read information, so number of reads, and then some metadata. In this case, referring to that, they've come from a suboxic environment. And then I'm declaring a data frame called data frame from dictionary of lists. And I'm saying pd.dataframe, which is the function to declare a data frame. And then inside the parentheses of that function, I'm putting the dictionary where each key is my intended data frame column header, and each value is the list of items from the lists I've declared above. Okay, for some reason it didn't clear my data frame. Sorry about my notebook output. So sorry, I'm going to clear all outputs. There we go. So now if I want to look at what this data frame structure is, and I can run this cell. Oh, right. I've declared all outputs. I'm sorry. So we'll do this, this, and this. There we go. So now this is what our data frame looks like. So we can see that our keys that we set up in that dictionary are the column headers. Each of those corresponding lists are the data that populates those columns. And notice on the left-hand side, there's the numbers 0 through 4 in bold, which is not a column, and those are the default indexes that Pandas has assigned the data frame. So if the user doesn't set something as an index, it'll just default to a numbering scheme. So here I'm going to show you how to actually set up the same data frame, but then actually use one of the data frame columns as the index column. So in this case, I've actually set up that dictionary to include just 2 columns, number of reads, and environment, and that's because I'm setting the index column to be OTU name. You can't declare a column of data to be the index in the same line, but we'll go over that after, how to declare the index after setting up columns. So I'm going to run this, and now we see that we have 2 columns, number of reads and environment, and then in bold text as the index column is OTU name. And this is a great capability of Pandas because this actually allows you to access columns of data by index. Okay, so another way that we can declare a Python Pandas data frame is using a list of lists. So what I'm going to do here is I'm going to take our 3 lists, and I'm actually going to make a big list of lists out of them. So I'm just doing that with a simple loop. So I'm counting and enumerating, and then appending the OTU name, the corresponding number of reads and environment type for each list within that list, which makes something that looks like this. So we see we have one big list, which is the outside square brackets, and that inside we have 3 smaller lists, which contain each data set of OTU, number of reads, environment. So now if I want to declare a data frame from a list of lists, I'm using that same pandas data frame function, but I'm calling my data big list, which is my first positional argument, comma, and then I'm setting the column names from a list of strings, because in this case, without the key value pairs to associate the data with a column name, you have to explicitly set the column name after. So now I'm going to run this cell, and let's take a look at what we get. And you'll see that by this method, you're producing the exact same thing that we achieved using our dictionary of lists method. Now, in this case, you can't really set your index in place as you're making the data frame, because you would actually need to extract all the OTU names by iterating over each of those smaller lists. So what you can do after you declare the data frame is set the index by choosing a column afterwards. So here I'm doing that using the pandas built-in set index function. So what you have to put in is the column name that you want to use. And there's an argument that's called in place. The default it is set to is false, meaning that it will not alter your original data frame, which is great if you want to preserve the original data frame structure. So then you can have in place set to false and just set this equal to a new data frame name. Or for my case here, I don't really care about that. So I'm saying yes, alter it in place equals true. So now if I run this and I then take a look at our data frame again, you see that we've set, once again, our index column to OTU name. And let's see. Are there any questions so far, or is this okay? Okay. So the final method is declaring a data frame from a list of dictionaries. Now, this is probably something that Ben is a fan of, because I know that he really enjoys storing all of his data as dictionaries. And it's a very common way to actually store bioinformatics data, and that's because you can use key value pairs for all your data, and it's very easy to access and organize that way. So let's make a big list of dictionaries. So I'm going to iterate over my lists in the same way as I did at the beginning, but in this case, I'm creating a dictionary for each set of key value pairs from those three lists, and then I'm appending that dictionary to an empty list. So if we look at what that creates, we see we have one big list, which is the square brackets, and that within that list, we have all of these dictionaries for each set of OTU number of reads environment. And this is a really convenient format to work with, because again, when we declare our pandas data frame, pandas will automatically recognize that those keys are intended to be the column headers. So now if I just declare my data frame as big list of dictionaries, and I set my index column as I did above, and look at the output, again, we see we achieve the same thing. And the reason I'm going over all these different ways is because within your workflow, you might be someone that works with lists of lists or dictionaries or what have you. So the best way for you to do this depends on how you work. So now I want to go over some of the more basic methods of filtering, exploring, and manipulating data frames, right? Because that's the whole point of using them. The basic indexing structure of the Pandas data frame is the data frame name dot column, and then your row is in square brackets. And you can access columns by doing dot column or placing the column name as a string within square brackets. I will say that you have to be careful, because if you have a column name with spaces or special characters, you must access it only by putting it as a string inside the square brackets, or it will break. You can actually call the rows and columns by their Python zero-based indexing positions, or by the row and column names. Rows can be called by .loc index or .iloc, depending on whether you want to use their position or your actual index names if you've set an index column. And also, if you've set an index column, you can access that information by dataframe.index. So here I'm going to show some examples of how to do this and access that information. So for example, if I have my data frame and I want to access my second row by Python zero-based indexing, meaning it's positional index, I can use dataframe.iloc. So if I run this, I get the output, which contains each column name, its associated data, and in this case, the name refers to index name. But you see, if we go back up, that it has actually indeed returned the second item, or in position 1. Now, you can also access things by using .loc by their specific index name, and this is extremely useful. So let's say I have the data frame and I want to pull up the entire row of the data entry with this taxonomy. I can use .loc, and that row will be pulled up by the index. So you can see that we pull up the same entry, and that the index using the index name, which appears here. Okay, so now let me show you how to access columns of data. So here I've have my data frame name, and in square brackets as a string, I've put the column header number reads. And if I run this, I get that entire column of data. And then notice that it still returns that with the indices at the left. So you're always going to see the indexes on the left side. And you get the name of the column at the bottom, as well as the D type, in this case, int64. So now that we know the basics of how to access data by row and column in different ways, I wanted to show you how some of these can be used in manipulating and searching data. So here I've given the example that if I wanted to know the number of reads, say for only entries that are gamma proteobacteria, I can actually filter my index column as a list, and then I can use .loc or the lookup by index function to call on that subset of data in my number of reads column. And the ability to conditionally sort and manipulate these data frames is what makes Pandas so powerful for handling large data sets. So here I'm creating a list called gamma list, and I'm just saying I for I in dataframe.index, which is my index column, if gamma proteobacteria in I. So I'm basically saying, give me a list of items from my index column if gamma proteobacteria is in that string. Then I want to access my column of data, number of reads, but only those. So I'm saying .loc, which is the index row lookup method, gam-l. So I'm passing in that list of strings. So if I run this, we see that as we've wanted, we have accessed only number of read column data with OTUs that contain the string gamma proteobacteria. So here's another thing I wanted to demonstrate, because this is such a common cleanup step. In a lot of bioinformatics data sets, you look through and remove OTUs with 0 counts or less than a certain number of reads. So let's do that here. Let's examine the data frame entry where there are 0 reads, and then we can actually create a Boolean data frame object and return that information where the condition is true or false. So I want to actually go through each step of this before presenting the final argument, because it's a nested structure that can often be very confusing if you lose track of where you are. So here's the first step. Here I'm testing, okay, in my data frame, in the number of reads column, equals 0. Now, equals 0, this is a Boolean operation. I'm saying basically return true if that number is 0, return false if it's not. Do take caution. If you accidentally use one equal sign, you'll actually accidentally set that whole column of data equal to 0 instead. Okay, so if I just run this step, you can see that here I have the column name, number of reads, data type Boolean, my indexes, and here it's saying false, 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 true, right? Now, if I go back up here to the data frame, I can see, yes, indeed, the last entry, that is 0, right? Now, if I take this chunk, this Boolean, and I put it inside the data frame in square brackets, I can actually access the part of the data frame that is true. So here in this setup, I'm saying, take my data frame and give me only the entries where this Boolean condition inside the square brackets is true. So you see the difference here, right? Rather than returning this Boolean output, I'm actually returning that subset of data. Now, if we use this kind of structure with the Python pandas argument.drop, we can actually then get rid of those entries. So the basic syntax of the Python pandas.drop method is dataframe.drop, then some condition .index. And there are some default settings to be aware of that you can change if you need to. So by default, for example, this will be performed along rows, axis 0. And by default, again, in place is set to false, meaning that it's not going to alter your original data frame unless you explicitly set that to true. Otherwise, you have to set it equal to a new data frame. I generally do not like dropping things in place, because if you make an error or you need to debug, you've lost the original data. So let's take a look at this. Here I have no zeros data frame from lists of dictionaries, equals because I'm not dropping in place. And I'm saying dot drop, and here's my Boolean condition, right? Inside. And then I have dot index afterwards, axis equals 0, meaning I'd like to perform the operation along rows. So now if we look at this data frame, notice that that entry is gone. There is an alternative method, the tilde method, which I like just because it's easier to look at for me. It's less crowded text-wise. And you can see it's actually much simpler in syntax. So you have data frame, and then you have square brackets, tilde condition. Now, if you remember above, when you want to access that subset of data in a data frame, you put it inside those square brackets, the condition. All that this tilde is doing is it's saying, give me whatever is not that. So if I set it up and run it that way, once again, we get the same thing. So that is everything that I wanted to go over